Okay, so in the next string of questions, you are going to be required to kind of look at the problem, figure out how to attack it. So I'm just going to run through really quickly, choosing a method. So the first thing you're going to want to think about is, or the first question, or maybe like what your immediate thought should be is, what kind of problem is it? Or maybe what I should say is, what type of equation? If it is exponential, then we're going to attack it one way, versus if it's logarithmic. Okay. Those are two different types and they get solved in different ways. So let's just run through exponential first because that's what we started with in our notes. So if it's exponential, are there powers on both sides? Because if there's powers on both sides, we want to look for common bases, right? Because then we can cancel those powers, right? That was our very first method that we studied. So common bases is one method, and it's great when you have powers on both sides. If there's only power on one side, then we're going to want to change to a logarithm. Right? If we can't alter both sides, then let's just hit it with a logarithm and see what we can come up with. Okay. On the flip side, is it logarithmic, right? Is there a log in the original equation? Whoops, my bad. And I'm on a race against the clock because my Chromebook just told me I have 5 minutes left. And that's not much time. If it's logarithmic, are there logs on both sides? If the answer is yes, then we should be able to get, if there's common bases, we should be able to cancel the logs. Oh, here comes Benton. Hang on. Okay, so you can cancel your logs if you get log on each side with the same base, sort of like common bases before. If there's not logs on both sides, then we're going to have to change it to exponential. And this probably resembles a chart that maybe you've seen before, but it's all about looking at both sides, and that means both sides of the equal sign. So if it's yes, that's something like 2 to the x and 8 to the x plus 3, or whatever, right? And so looking at that, then that would be sort of log on both sides. This would be something like... Okay, buddy. Sorry, Benton's talking to me. 2 to the x equals 7. Now there's only one exponent. Same thing with logs. If you've got log on both sides, then maybe you have log x equals log x plus 2 or something like that. And no would just be that log x equals 7. I'll just keep using 7. And so you have to decide how many logs do I have, and then how does that impact the equation. So thanks for your patience, and hopefully this helps a little bit. If you think this would be helpful to have as like a printed out form, you just let me know.